The Pythagorean theorem in geometric terms is a relationship that states that if a square is constructed on each side of a right triangle, the area of two smaller areas will together equal the area of a square on the longest side, the hypotenuse. The Pythagorean relationship 19.22 activity. Have students draw a right triangle on 0.5 centimeter grid paper. Assign each student a different triangle by specific the lengths of two legs. Students should draw a square on each leg and a hypotenuse, and find the area of all three. For the square on the hypotenuse, the area can be found by making each of the sides the diagonals on the rectangle, as you see in the figure below, with the red squares. In the other figure, there are two large congruent squares. Together show visual proof of the Pythagorean theorem. Notice that both large squares are decomposed into squares and triangles, and that the four triangles in each large square are the same but arranged differently. By adding up the areas of the squares and the triangles in each area of the large square and setting them equal to each other, the Pythagorean relationship can be found by subtracting out the common areas in both. Transformations are changes in the position or size or shape and are major focus on in middle school and high school grades. Movement that do not change the size or shape of objects moved are called rigid motion. Translations, reflections, and rotations are rigid transformations, as you can see in the figure below. Transformations. A translation slide requires a direct and distance. In the translation, every point on the pre-image moves in the same direction for the same distance to form the image. In the reflection flips requires a line of reflection. A reflection is a transformation in which an object is flipped across a line of reflection. A rotation turns requires a center of rotation, a point, and a degree of rotation. It can be on the shape being turned or away from the shape being turned. Lines of symmetry. If a shape can be folded on a line so that the two halves match precisely, then it is said to have a line of symmetry. Sometimes it's called reflection or mirror symmetry. Notice that the full line is actually a line of reflection. The portion of the shape on one side of the line is reflected to the other side. This is the connection between line of symmetry and transformation. One way to introduce lines of symmetry is to show examples and non-examples of all these and none of these approach, as you see in the figure below. Activity 1926 corresponds with the figure on the right. Give students a piece of 1 centimeter isometric dot paper. Students should draw a line through several dots. This line can be horizontal, vertical, or diagonal. Students make a design completely on one side to draw the line that touches that line, as in the figures you see here. Have students make a mirror image of their design on the other side of the line, or have them exchange with a partner and have them try to solve the problem. As an example, you can have students draw a shape on a dot paper, then the curve draw along one side that might be translated or a slit to the other side. Another idea is to draw a curve from the midpoint of one side to a adjoining vertex. This curve is then rotated about the midpoint to form a totally new side of the tile. As you can see on the left, here's an example. Congruent shapes are defined in terms of transformations. Two figures that are similar if all the corresponding angles are congruent and the corresponding sides are proportional. A dilation is a non-rigid transformation that produces two-dimension figures. The dilation can require a scale factor. Scale factors less than 1 are smaller and greater or larger. Hidden positions. Give each student a hidden position game board. Two students, it sits with a screen separated with their desks. Space on either side, students can see each other's grid. As you see at the bottom middle example, each student has 4 different pattern blocks. The first player places a block on 4 different sections of grid. He then uses words to tell the other player where to put blocks on her grid to match his own. When all 4 pieces are positioned, they can check. To describe a location, students need a reference point or an origin and information about distance and direction. Use a coordinate grid like the one shown on the top right in the figure, and explain how to use two numbers, positive whole numbers, to designate an entire section point on a grid. Activity 1933, Coordinate Reflections. Ask students to draw five-sided shapes in the first quadrant of a coordinate grid. Label the figure A, B, C, D, E and call it figure 1, as you see in the bottom right figure. Use the y-axis as a line of symmetry and draw a reflection of each shape in the second quadrant. Take a look on page 535, activity 1935, 1936, 1937, 1938, and 1939. These will help you explain all these different figures on this slide.